So today in this video we'll talk about how vector is used in physics. Let's get started. In the video before, I explained how it is used in computer science to store data. In physics, vector is usually denoted by this. In order to denote a vector, you use angled bracket like this instead of the typical brackets you use to denote a coordinate. So the first thing we have on top, it's always the horizontal component, and then the second thing we have on the bottom, it's the vertical component. Let's get rid of all this. Okay, so here we can see that the space of this horizontal area is 2, and then vertically the space is almost 1 unit. So that's why this vector has the horizontal length 2 and vertical length 1. Next, in vector, the first thing you write is always going to be the horizontal, and then the second thing will be the vertical component. And here order matters. You can write first you can write the horizontal component, then the vertical component, but you cannot write the vertical component first, then the horizontal component second. It's wrong. So vectors can also be negative, not only positive. So this was the vector we discussed before, right? And both the components were positive. But here we'll see what happens when a vector's component is negative. Firstly, we take the case of negative horizontal component in a vector. Here in this vector -2, 1, this vector is facing in the opposite direction. The vector we had before was facing right, but now it's facing left, so it's negative. And then another vector we have, which is -3, -1. Now it's facing negative on both directions, both the horizontal and then the vertical. It's firstly facing left and then going down. That's why it's negative on both ends. So remember this. If you go left, the horizontal component will be negative. If you go right, the horizontal component will be positive. And if you go up along the grid, the vertical component will be positive. And if you go down along the axis, the vertical component will be negative. Now let's look at this point. Firstly, we have the points 1, 1. Then we have the points 3, 3. Now, does this point exist anywhere else in the grid? The answer is no, right? Each point has a unique position within the grid. But when we talk about vectors, it does not matter where it's positioned. That's what physics says in case of vectors. So here we have 3, 2, 1 vectors, like 3 vectors having the configuration of 2 horizontal component and 1 vertical components, right? And they exist in 3 places. Now, these vectors are called equivalent vectors. They have the same value, but they exist at different places. Now, we could shift them all in the same direction and nothing would change. Wait, look. This is the reason why they are called equivalent, because they fit exactly on top of each other. Still not clear enough. Look, it almost feels like they were copied and pasted off of one another. So that's why we call these vectors equivalent, and they can exist anywhere in the plane, right? So I can draw another vector here. Look. And this is also 2, 1. So there's difference between points and vectors, especially in physics. Now we can talk about vectors in 3 dimensions. Now it's the same thing, basically. Firstly, we have horizontal component, then we have the vertical component, and then we have the height. This is the extra part. Again, here order matters. So I'll show you how it looks on the grid when we try to graph 2, 3, 1. So this is the vector, the red part, this one. is the vector. Looks like this. On the xyz plane here, I'm showing you the y and the z axis, and you can see this is how the vector looks from this perspective. But if we were to look from another perspective of xy axis, this is how it will look. We are only projecting the horizontal view, and then when we add the height, it looks a bit different, right? So yeah, this is how vector is used in physics.